If you've got a question, the voices of resin are here. Oh, PlastChicks.
PlastChicks is an SPE sponsored podcast.
Hey, Lynzie.
Well, hello. How are you today?
I'm good.
Office number 2, just living your best life.
Just living my best life. Yeah. So, of course, this, will probably get aired months after, but I just got a big promotion. So I'm now overseeing both of our labs, Peacock Colors and Vortex Liquid Color.
Well, why don't you introduce yourself while we're at it with your new
title? Well, thank you so much, Lynzie. And you have a new title since we last recorded too, or no?
No.
Well, it depends on anyway, I am Mercedes Landazuri. I am Director of Technology and Innovation for Peacock Colors and Vortex Liquid Color, and serve on a few boards for Society of Plastics Engineers.
And I am Lynzie Nebel. I am an upstream product quote engineer for Cytiva, and I am the VP of member engagement for SPE, and on the Diversity, Equity, and Inclusion Board and the Injection Molding Board and the Northwest Pennsylvania Board.
All the boards. And with our powers combined.
Oh, yes. And with our powers.
We are PlastChicks, the voices of resin.
That might have been our worst one. Best timing wise, worst because
longest one. Yeah.
Else. It's fine.
It's fine. They can totally edit this out. It's like all done with mirrors and.
Yeah. Honestly, I think we're probably one of the podcasts that's giving them like the best crack at editing podcasts.
Right. This is just, put that on your resume. So on our podcast, we talk about all things plastics, all people who work in the industry and parallel to it sometimes. You can listen to us. We release the episodes first Friday of every month on Apple Podcasts, Google Podcasts, Stitcher, Spotify, wherever you get your podcasts. PlastChicks, find us on social media. Mm-hmm. It's not PlastChicks, but you can call us PlastChicks. Just PlastChicks. Yeah.
Put it in the chicks part. And we are also on SPE's YouTube page. You can find the live video version, the recorded live video version, and you can see what great color lipstick I'm wearing for each episode.
It's a great color today.
That's really focused. Thank you.
But enough about us.
Because we have a guest here. Because that's what
we do. Have a guest. It's not just us. Hello.
So today we have Jason Brownell from Polyfuze.
Oh. Hello.
Yay. Welcome, Jason.
Well, thank you so much, Mercedes. Congratulations on the promotion. It's awesome.
Thank you.
Yeah, thank you for having me on as a guest, and look forward to talking with you guys today. So I'm the Director of Engineering over here at Polyfuze, and I don't know if you'd like me to kind of go into some history on where we kind of come from, or if that comes later. It's
absolutely. Give us the spiel about Polyfuze.
You got it. So we're very much a niche company, specific to the polyolefin family of plastic. So all your polyethylenes and different derivatives, polypropylene, even as it gets into soft touch material like TPV, for example. That's strictly what we help people to label, which is also one of those materials that's very challenging to try to label. So the owner of our company invented this technology, well, let's say 35 plus years ago.
Wow.
Understanding that there was a need, and as the history is concerned, he had worked for a plastics company, and one of the major restaurant chains was having a problem where the containers that would hold the coffee and then also the milk, they were getting mislabeled because the labeling was coming off. So all of a sudden your milk started to taste like coffee, and it was just an issue. And so, what's that?
I said that wouldn't be the worst thing in the world.
Yeah, I don't mind that at all.
Coffee milk.
True. And so that's kind of the challenge that they were up against. And then And then he developed this technology. And the name of that company is Molding Graphic Systems. And that was really geared towards people in the rotational molding industry. We would also do a lot of work with blow molding and thermoforming, and never really had a good solution for injection molding because of the speed. Everything on the molding graphics side is very hands-on. It's a slower process. And even though there was a need in the injection molded industry, we just couldn't keep up with the speed. And that's where Polyfuze was born, because it addressed the speed issue as well.
I mean, injection molding is the bestest molding, as I will say from time to time. And I believe that's an industry standard. I don't know. Yeah, I mean, that. Go ahead, Mercedes.
Oh, sorry. So how long has Polyfuze been around?
So let's see. I believe it was 9 years ago that Polyfuze first debuted.
Very young.
So what's that?
Very young company then.
Yeah, for sure. And to kind of explain how we tackle the failure modes of decorating polyolefin materials. So number one, as you well know, and as will the listeners, polyolefin materials has a very, very low surface energy. In fact, if you look at it, guys.
Jason, I think
we're losing your audio quite a bit there.
Yeah, your audio's almost down to nothing.
So, Jason, can you explain to us what is fusion labeling and how is it how does it differ from IML in mold labeling?
Absolutely. So earlier I was starting to say that for an adhesive-based technology to try to work, you have to have a relatively higher surface energy. And so oftentimes companies will plasma treat or corona treat in an effort to try to make an adhesive technology work. And so in order to understand how different the fusion technology is versus an IML, if you think of an IML on a cross section and think about the construction, oftentimes you will have a clear coat on top with a layer of ink underneath that. And then underneath that, you have a tie layer or a substrate that does a very, very good job of mechanically bonding to the surface of olefin-based materials. The trouble is you have that clear coat and the ink. And if that clear coat breaks down for whatever reason, could be related to UV, could have, scratching, things like that, just from, being in the world. If that clear coat starts to break down, then those inks go away. And so at the end of the day, then what you can be left with is just that tie layer or the substrate layer. So fusion labeling is so different in that, number one, it doesn't utilize ink whatsoever. We're actually printing with pigmented polymers. And I often think of ourselves much more as a, what's that?
Mercedes' favorite is anything pigmented.
Yeah, there you go. And so we're working with pigmented polymers, and I often think of ourselves as a polymer company much more so than a printing company. And so what's basically happening is you're taking our plastic label, the fusion label itself, and you're putting it in contact with the olefin-based part. Then you're applying heat to those two materials. And so you're reaching the melt temperature of the plastic label, you're reaching the melt temperature of the plastic part or the skin of the plastic part. And because the two are the same material, they fuse together to become one piece of plastic. And so, we've taken cross sections of it and look at it under, like, say, semanalysis, and you can see on a molecular level where things are just fused together versus being a bunch of series of layers. And so that's what's so different about fusion labeling versus any other sort of decorating method that's out there. Because you have screen printing, you have pad printing, you have traditional adhesive based layers. You mentioned IML, heat transfers are out there. All of those are trying to make things bond or stick. In fact, a lot of times when I send somebody a sample of our materials, and they'll call me back and they'll go, wow, these fusion labels really stick. Like, they don't stick at all, because they don't. They're actually fused together versus adhering. So hopefully that kind of gives you the difference between fusion labeling versus an IML. It actually becomes part of the plastic.
Gotcha. So with the fusion labeling, do you have these different layers as well? How many layers are there, or are there not really layers?
There's not really layers, other than the fusion label is going to be printed on a carrier film. And that carrier film is just to get the printed material from us to the manufacturer. At that point, the heat then is applied, and that carrier film that we printed on is then discarded. Okay, so it's just a carrier to get the pigmented materials to the plastic. And people will hear the name Polyfuze, and they'll grab hold of that we decorate polyethylene, polypropylene, and so they'll oftentimes jump to a conclusion and say, oh, so you can decorate polystyrene and polyurethane and polycarbonate. And it's like, no, it's not the same kind of materials. So again, we're very much a niche company in that we stay in the olefin family of plastic. That makes sense.
Yeah. So so I'm picturing this printed film kind of like almost as like a temporary tattoo type thing, where it comes off and then
kind of yeah. That's what it looks like. And and it is, when it's in its raw form, there's nothing durable about it whatsoever. It's very soft material. You can wipe it right off, if you will. But once it comes in contact with the plastic part and it gets heated to its melt temperature, the olefin-based material and the fusion label, they're going to melt somewhere around 300 degrees Fahrenheit. And so the piece of equipment that is used, most people in the injection molding industry already have either a hot stamp machine or a heat transfer machine. So we're going to ask that they make some modifications in that, rather than using a steel or a magnesium die, you're going to want to remove that die and replace it with a silicone rubber die. And then typically when you're talking about hot stamping, heat transfer, they'll run the machine at about 350 degrees Fahrenheit. And that's because what they're trying to do is activate an adhesive in a hope to make it stick. We're going to crank that temperature way up to like 550 degrees Fahrenheit. So when that 550 degree machine with the silicone rubber die comes in contact with the label and the surface of the plastic that are all going to melt around 300, that fusion process happens very, very quickly. And at that point, it is there and it's labeled for the life of the plastic. There's nothing to delaminate or come off it. It's part of the plastic. In fact, I would say once every couple months, somebody calls me up and they say, hey, by the way, I put my logo or my warning on upside down. How do I get it off? And you don't. I mean, short of taking off layers of plastic, it's part of it. It's fused into it.
So how do you prevent like deforming the print? I mean, can you mess that up? Because I feel like I would be able to mess that up somehow.
Yeah, depending on the type of material, everything's going to have a little bit of, different melt temperatures. It's a very low pressure system. Low density polyethylene versus, ultra high molecular weight polyethylene versus polypropylene. They're all going to have some different characteristics. And yes, from an aesthetic standpoint, you can sit on it too long and kind of distort the image, if you will.
Listen, I burnt my little apron that I made at my 3rd grade birthday party. I held the iron on too long. I was too excited. The horse's head melted right through the iron. It was upsetting.
Don't even get me started on like what her phone screen looks like when she tries to put the legs part on top of it to protect it. Bubbles until it's completely cracked.
Someone else will do this for me. Thank you.
So funny. So funny.
So what kind of applications are you seeing for this? Is it mostly for packaging? Are you getting into automotive at all, where the labeling standards for that have changed, I know, recently?
They have. And yes, we're highly involved in the automotive industry. Platforms with General Motors and with Ford. And it's interesting because when you look at labeling, you have, permanent labeling, versus temporary labeling. And the documentation that I have seen, permanent labeling requires like end of vehicle life, 15 years. Mm-hmm. And that's something that as an organization we addressed, and we said, sure, we can be there for 15 years. And then started thinking about it, if it's properly fused into the plastic, it'll be there for the life of the part. And so that's something we now offer. It doesn't stop at 10 years or 15 years. It's for the life of the part. But yeah, we're very much involved in the automotive space for sure. Companies like Rubbermaid, for example, do a lot of things, within those types of industries. Do a lot of things in the outdoor sporting arena. With coolers and kayaks and things like that. And it was interesting because when we first, came into the industry on the Polyfuze side of things, everybody was used to really small images. In fact, I was cautioned by one person early on that said, if you're going to try to do this with a vertical piece of equipment, the maximum size that you can do is 15 square inches. That's it. Like 3 inches by 5 inches, that's it. You're done. Mm-hmm. One of the largest ones that I worked on, I believe it was 12 inches tall, 24 inches wide on a big snowplow blade. Wow. So yeah, I mean, we're kind of, the industry itself is kind of looking, going, this is different, it's very different.
Are you limited to geometry? Shape, you're saying a snowplow blade, there is a curvature to that. Does it have to be a flat surface? Can you go, in the Z dimension?
We can, but it's relative to the part, the compound curve versus the size of the label that you wanted to do. This isn't going to be a situation where you can necessarily wrap around a part. Just because of the complex curves that are involved. And oftentimes I use the analogy, it's kind of like putting a piece of paper on a basketball. If you were to take a 1 inch by 1 inch piece of paper and put it on a basketball, no wrinkles, not a problem. You try to take something that's 10 inches by 10 inches and put that on a basketball, it's going to be full of wrinkles. So that's one thing, understanding that we're printing on a carrier film. If that carrier film wrinkles for whatever reason, then that's going to show up in the finished part.
But like certainly wrap a basketball, which is not an idea I would recommend.
I've tried to give those gifts to my kids before. Never looks good. Never looks good. I was using the wrong technology for sure.
Wrong technology. This is not a Polyfuze application.
Yeah. So what's like one of the most kind of unexpected part that you've gotten to fusion label?
Quick story, and then I'll get back to that. One time I was in a manufacturing facility, and this goes right in line with what you were asking before about distorting things. I was working with a manufacturing team at an injection molding facility, and they told me that the power was going to go out in about 30 minutes. And so I had 20 more minutes in order to stamp parts. No problem. I was working along. I was almost done. I still had 10 minutes to spare, and I was decorating the last part. That hot dye came in contact with the label and the plastic part, and the power went out. And there it sat with that hot dye in its down position. And it sat there for a long time, about a minute and a half. before the power was able to come back on and we were able to get that die head off. And what's interesting is the label itself looked great. It was just about a ½ inch down into the part where it shouldn't be, just because it was so hot. But you know, back to the interesting part, and working on that snowplow blade, I would have chosen that as one of the stories of an interesting part, because it was so big, and it was unheard of in the industry to try to do something like that. So even though that kind of ties in with what I was talking about earlier, I would say that was an interesting program for sure to work on.
Yeah, I mean, I guess that would be pretty cool if you think about it, you know, being able to brand on your snowplow. Like, that's not, my dad was the highway, he worked for the highway department for years and years. So,
Sure.
I mean, it would have been cool if they could like put their names on there, you know, because they all have their own trucks.
Yeah.
Not that the highway department would be paying for that, but still, it would be cool.
Yeah, I mean, even if it weren't like personalization, if it were like customized to like that department or the township or whatever.
Exactly.
Well, and that's just it. You know, a lot of times people will look at fusion labeling for branding because branding is very important. But a lot of people will come to us because of warnings and instructions. And, you know, these are things that, you know, from a liability standpoint, if the instruction needs to stay there for the life of the part, and then it comes off for some reason, you know, that's not great. And so, again, a lot of times people think of us, you know, as helping with their branding, but it's really important too with warnings and instructions. In fact, it was kind of interesting, you know, when we look at reusable packaging, for example, you know, rather than doing like single-use transportation of goods, to be able to have something that comes back. There are task force that are set up to try to combat unauthorized recycling of plastic. You know, where people will steal plastic totes and pallets and then grind those things up for money. And so for those people to be able to have their name on it and say, you need to contact us, you know, no, you know, unauthorized recycling allowed, and to have things like barcodes, for example, that's another big one. People, when they have their assets that, you know, are leaving and they want to get those assets back, it's important to be able to track those. So that's another big thing that we're doing quite a bit of now is just from a barcoding standpoint, you know, whether it's code 128 or 2D data matrix, people are wanting to capture that information too.
Sure. And that makes sense too with, I mean, those trends in like the, oh gosh, why can't I remember like with the refillable consumer packaging and things like that. I would say it would go in line with that as well.
Yeah,
cool. For
sure.
Yeah. So
it's fun stuff.
You know, you're talking about the, you know, bringing packaging back to, you know, whatever place it came from. So that way it's kind of a looped recycling system. You know, where do you see the responsibility of, you know, packaging industry, but also like someone that's not necessarily driving the packaging like you guys are, but you play an active role in the packaging? You know, where do you guys kind of see yourselves in that?
Yeah, again, with not doing single use, but, you know, working with pooling companies and things like that to get those assets back. It's important to note too that when they do come back, oftentimes they have to be cleaned. And so, you know, it's important that labeling will stay on that plastic tote or that pallet, not only for the life of the part, but, you know, it's going to survive all of the detergents and, you know, washing and things. And we see this a lot in the medical industry as well, where, you know, you will have multiple trips with containers where they have to come back, they have to be cleaned, maybe autoclaved. And it's important that the labeling and the identification on it stays with it for the life of the part. So yeah, we're definitely very much involved in that. And we help people with managing those assets as well.
Mm-hmm. So does Polyfuze sell the systems, or do you sell it as a service?
No, we're selling the individual transfers.
Mm-hmm.
And so, oftentimes we'll work with plastic injection molders who are making product then for, say, an OEM of
Mm-hmm.
sort. And so we're just producing the labels, we're shipping them to the manufacturer.
Gotcha.
Then the manufacturer is doing it on their end. And again, so there's a lot of different scenarios that kind of take place. Sometimes people are doing it right at the end of an injection molding cell.
Mhm.
They're taking advantage of the heat from that molding cycle.
Sure.
The part may come out and it's 130 degrees Fahrenheit. Well, you're already over a third of the way to the melt temperature of that material. Versus you could also do this in a secondary situation where you're decorating parts out of an inventory. The parts may only be 50 degrees Fahrenheit, and it's still something that you can do. It's just going to impact, how long that die would be in contact with the fusion label and the plastic part. If that makes sense.
Equipment wise, there's nothing that you guys offer as like a package or anything, or like a starter package. It's all modification of, hot
Heat transfer
or whatever.
Yeah, exactly. And fortunately, most people that are in the manufacturing space already have that capital piece of equipment. So yeah, we're not offering any sort of equipment, but we do work with the major equipment manufacturers. And back to your earlier question regarding curved situations or curved parts, that it doesn't have to be flat. We actually developed a line which we refer to as our VersaFlex system, where it's actually put on with a very, very soft silicone rubber pad, similar to what you would see in the pad printing industry. And this allows people not only that have curved parts, but also that may have hollow parts that they need to label. Because a lot of times you can't get in and support the underside wall of a part that's hollow. And so to be able to go in with a low pressure system and help people in those instances as well. And that's known as a VersaFlex.
Once again, that would be me just crushing that part, and it would just come out all wonky. And
right.
Yeah, that's kind of my brand, if we were.
So awesome. Love it.
So how does this technology compare with other labeling technologies from a sustainability perspective?
Yeah, well, because it becomes part of that thermoplastic, it is 100% recyclable with that plastic product when it reaches the end of its life cycle. So it can be ground up then and made into something else. So it's not any sort of a foreign substrate that needs to be removed. It can just be ground right up with it because it is part of the plastic. So yeah, 100% recyclable.
And now I'm not sure if you guys have done a lot of testing or thinking of, because color is, my world. So that's what I'm thinking about. Oh, wow, cool. So you're coloring these actually with pigments and not with inks. So have you done, and thinking about this is like a long-term, ostensibly for the whole, life or the use of this specific product, it would be on there. Have you done any sorts of weathering testing and color fastness testing for these labels?
Yeah, absolutely. And we have an extensive test data report that, we can provide to anybody if they want to take a look at it. So not only have we done accelerated weather testing with like QUV test equipment, but also, we have the luxury of being in Arizona, where we can do long-term studies as well and pull them at different intervals. So yeah, definitely from a weatherability standpoint, we have a lot of data, but also from impact testing to chemical testing. I'm never worried about anybody doing any sort of testing with our label, because if your plastic will hold up to whatever test you're performing, So will the label. It's part of it. And, so short of removing layers of plastic, it's part of it. So when we do chemical testing, it's not just a chemical wipe. We'll soak them for hundreds of hours. In fact, on our campus here in Arizona, we actually have test tubes that I think were set up, a long time ago, that has our labeling technology in it. So with all sorts of various chemicals. So least of my concern, but yeah, definitely a lot of weathering testing.
Yeah. So, kind of switching gears a little, you guys are as we established earlier, a younger company, kind of born out of an older company.
Sure.
How, the plastics industry itself, a lot of these companies are, generational, family owned, been in, especially in the injection molding world, a lot of those were started by somebody's great grandpa or, whatever. How do you guys interact with kind of that established, I love the injection molding industry, but sometimes, something new and jazzy is a little scary. How do you guys
we'll just continue using what we've always used, and how do you combat that?
Well, first off, as far as family owned, we are a family owned company, second generation, and so from that standpoint, we can relate sometimes to the folks that we're working with. But you're absolutely right. I think sometimes people are fearful of change. But one thing when it comes to working with olefin-based materials, it doesn't take very long with talking to somebody for them to admit the challenges of trying to decorate that material. And when you start asking questions about, well, do you do any sort of secondary process in an effort to try to raise the surface energy? Do you do plasma treating? Do you do corona treating? I really look at our company as we're providing a solution for people, because everybody that works with this material has challenges with it. And we're not a fit across the board with every single product. But certainly for people that are struggling for parts that I would consider durable goods that has a life cycle of 10, 15 years, if the life cycle of a part is 6 months, then we may not be a good fit for that. And certainly sometimes if the labeling comes off, it's okay. It was just meant to, get to a consumer, for example. But if it's something that needs to be there for the life of the part and it's a durable good, it doesn't take very long for people to understand those challenges. So.
Yeah, I could see that as pretty helpful. But I think to me, I would almost be more concerned because I would be like, well, what if I want to change something? I would not want to be the person proofreading it. That's for sure. Like, that is not where I would feel comfortable. It would be like THIER or something dumb like that.
Oh, it's definitely going to be,
Yeah.
Something like really big and bold, just like misspelled.
Yeah, it would be like
letter
warning, WRAN, and I'd be like, no.
Awesome.
Yeah. So, is there anything else that this industry should just know about? You guys have a really great marketing. I was poking around on your website. I love the tattoos for your parts, which I think is very cool. Kind of goes with your young company vibe. I did give my sons both Spider-Man temporary tattoo sleeves last night, so we're on a pick right now.
Well done.
So is there anything else, that you really think people need to know about your company and what just, I think it's kind of obvious what sets you guys apart, but is there anything else, to really sum up Polyfuze?
Yeah, right now we're very much in an educational phase. When I look at engineering drawings, I will see different categories of decorating methods or labeling methods, and we don't fit in to any of those. We're not an in-mold label. Well, we're not hot stamp foil. We're not a sticker, and it's almost like it needs another category. Not Polyfuze, but fusion labeling really is a category of its own. And so trying to educate people, people coming out of university, and so that people understand that there's another way to try to label these challenging types of plastic.
Is there, so kind of to piggyback off that question, is there an industry or an application that you see? Because it's like, okay, I definitely see how this would fit into automotive with the need for, these long lasting labels. Nice alliteration. Long lasting labels. And then, as you mentioned, medical with, the chemical resistance. Are there other industries you feel like Polyfuze could or fusion labeling could really be well suited to that hasn't really gained much traction or interest yet?
Well, I think even as we look to the ones that you mentioned and that I had mentioned before, there is so much plastic being utilized in those industries, and the penetration into that space, if you will, is so minimal. There's when I walk into a hospital or a doctor's setting, there are so many things that are made out of olefin-based materials. Same thing when you look at automotive. You have things interior, you have things under the hood, and now with the electric vehicle space and the olefin-based materials that are involved in that, those are industries that still could utilize it. Hopefully that helps to address the question, but yeah, we're in a lot of different spaces, and those are just, some of them. But again, outdoor sporting, coolers and kayaks and stand-up paddle boards and all those types of things. Again, those are items that, have 10, 15-year life cycles. So yeah, if it's olefin-based material and it has, a life cycle 10, 15 years, then it's applicable for us to work together. So,
oh gosh,
again,
even like college sports team stuff, or like, customization for teams and things like that for those types of parts. That would be huge. But okay, now tell me, because my very first love, my very first thing that I ever molded for just a couple of years, it was like all polystyrene. So are you exploring that, or is there just not enough of a market for that yet?
Yeah, we really stick to the space where people have the most challenge, being polyolefin-based materials.
Gotcha.
As we start to get into like styrenics and things like that, there's definitely things that'll stick okay. But when it comes to the olefin-based materials, that is definitely our forte, and that's where we shine and want to help people. So again, I really hope to get the word out that it's not just a labeling company. It's really understanding a person's challenges and then giving them solutions to try to fit their needs.
And I imagine, as you go into like more of the engineered resins, it would be really tricky to take those temperature profiles up even higher.
Right.
Yeah.
And we see that, we have people come to us all the time with requests to, come up with a solution for nylon, for example.
Just thinking, that's exactly what I was thinking.
Yeah, and they're like, please. And the temperature profile is definitely a challenge for sure.
They're little toasty parts.
Yeah, a little bit.
Oh, all right. Well, I think we are coming up on our hour.
Awesome.
And so, Jason, it has been awesome having you on here. Love learning about something that, we don't see in just the standard run-of-the-mill supply chain. So it's great taking a look at, this technology, especially because I think, I'm positive the only time I've ever heard of it is through you guys. So
right. And that's the goal, is to become a household name when it comes to labeling olefins.
The Kleenex of fusion labeling.
Yes, totally.
We'll use that as the tagline. Don't you worry.
Awesome. Appreciate it.